Okay, everybody, so what we're going to do now is try to start getting a grip on converting values in metric values in terms of its orders of magnitude, or basically in its scale. So we have grams, we have meters, we have liters. This is a gram. This is a tiny little piece of mass. This is a liter. And this is a meter, so we can actually see these things. I'm going to have them in the lab all the time. You can always refer to this. So if I'm wanting to convert, say, a gram to a kilogram, this actually has stamped on it kg, kilogram, we know that it makes absolutely no sense to say that 1 gram is 1,000 kilograms. You may remember, kilo means, 1,000 of something. Well, some people may think, well, that means take 1 gram and move the decimal 3 places to the right. Well, that makes no sense, because you can look at a gram and a kilogram. This isn't 1,000 of these. It's actually the reverse. This is 1/1000th of this. So what we're dividing by 1,000 here, and we know we can do that because we're canceling the grams, and that's still math, canceling values when you're multiplying fractions. And so what happens is we took that gram, and we basically, when we divided by 1,000, that's the same thing as moving the decimal place 3 places to the left. So what we're saying is that, and that makes sense because on our base 10 system, we're jumping orders of 10 3 times, depending on which way you're going. So if this is 1/1000th of a kilogram, that is the same thing as 1 times 10 to the -3rd kilograms, because if you punch in your calculator 1 times 10 to the -3rd, it will return, unless it's been programmed differently than the default way, it'll spit out 0.001. That's what will happen, because these are equivalent values. What it's saying is that this is 3 places to the left of 1, 1, 2, 3. So this is actually also written what's called scientific notation, which we will get into in a couple more videos, but let's not worry about what that is right now. But it is scientific notation. It is based on all this. So we got to get, once we get the metric foundation done, we will get into scientific notation. So let's also take a look at an example of volume. So let's say that I have here this little graduated cylinder that measures 10 milliliters, okay? And then this is a liter. So if I have 10 milliliters and I'm going to convert it into a liter, well, obviously, once again, that's a fractional value, okay? So 10 mils, as we know, it is based on millis. Millis is 1/1000th of a liter. So once again, we're essentially dividing by 1,000 with this relationship that tells us that for every liter, we have 10 milliliters. And so this is 0.01 liter. This is 1/100th of a liter. What this is saying is, practically, I would have to fill this up 100 times to fill this up. Okay, so that's also what is being expressed here. And if we want to put it in notation, that's 1 times 10 to the -2 liters, because that is 1 with the decimal place moved negatively 2 times. So this is the same thing, okay? We could also do this. We could, if we have in this graduated cylinder 53.5 milliliters, we know that isn't 53,500 liters. It's a fraction of 1. It's going to be, once again, less than. So that makes sense that if you're a beginning student in metrics and you have 53.5 milliliters and you're told to convert it into liters, we know, oh, well, that's 3 placeholders over. Don't be the student who thinks that means moving the decimal to the right 3 places. That makes no sense because you can see that it makes no sense. All that liquid that went there was not 53,500 of these. That makes no sense. It's clearly a fraction. Your eyes are telling you that the decimal place needs to be moving 3 places to the left. That is what your eyes are telling you. That is what is correct. Not this. Let your eyes tell you. You're going to be looking at this equipment all the time. Let it help you in really getting a sense of how to naturally know how to move things back and forth. Conversely, if I had written the question, what is this in microliters? Notice that my micro looks different than my milli symbol. Well, that's 3 placeholders, but we're going from a bigger value to a smaller. So yes, in that case, we are now moving the decimal place 3 places to the right. That's 53,000 microliters. Microliters is so small, my normal glassware does not actually have the ability to measure something that small. There are better labs than this one that can, but that's outside the scope of something that we would even be able to really see more than like barely as a tiny speck on a table. But once again, you have to really think of this. Micro literally means a millionth. Milli means 1,000th. So if this is a liter, this is down into the thousandths of the liter. We can still see it. Well, micro must be really small. So once again, try to really visualize what these conversions actually mean in real life in terms of volume, in terms of mass, or in terms of length. Once you get the hang of that, this stuff doesn't seem all that difficult, but it means us getting used to actually learning to measure in lab, and eventually this will seem very natural.